Hey guys, this is Mr. Ng going over a old chapter 1 test here. And the numbers are going to be out of order because I deleted some questions that didn't pertain to what I taught you guys for this class. So the following Stemleaf plot represents the scores for 30 students in an exam, stats exam. So remember, N here represents how many people or data points we're talking about. Remember, stem and leaves, these stems here are times 10. Now this one's kind of bad because it doesn't tell us a key. Usually they'll have something like they're telling us that represents 51. So the stem there in blue represents tens, and then everything over here is ones. And it will always represent one number, so even if you have hundreds over there. So find the mode for all these numbers. Now, I can expand all this and say, well, this is 32 and that's 33, but then we can just look at all the repeating numbers, and that might be a little bit faster. So let's go ahead and look through there. I have a couple of 6s there, 2 5s, and then I have all these 4s right there. And that represents an 80 and a 4. So this is 84 is our answer for number 10. All right, number 11. Based on the distribution of the shape of the stem and leaf plot, choose the correct statement that describes the relationship between the measures mean, median, and mode. Okay, so if I look at that one, see if I can pick a color I haven't used. How about red? And I come up here, and where this is, I'm going to draw a kind of graph, my distribution's a fancy word, and let's see if we can move that. Let's see, I don't know, it's gonna make me move off of it, but, and can we spin it around? I can't spin it around. I tried. But essentially what's happening in that data, if you see that in red, you see there's no data to the left, so you have basically a skewed left. Let's quickly just draw a skewed left. There's no data over here to the left except for that outlier over here. What does that mean? Well, your measures of center here in white, that would normally be your mean, median, and mode. But because of this outlier, the mean is not resistant, can't say no, and is being pulled in this direction. And then the median, let's pick a different color, is resistant. The median is the most resistant, which basically means it doesn't really move with outliers or extreme values, okay? So over here are small numbers on the left, and over here are bigger numbers. So if the median stays and the mean changes, that means the mean is smaller. Let's see what we got over here. So we can say the mean in blue is way over here with smaller numbers. The mean and median, the mean moves a little bit, and the mode is going to stay the same. It doesn't change. So the mean is smaller than the median, and the median is smaller than the mode. The median changed a little bit, but not by much, and so you have an answer here. That choice is B. All right, let's go on to the next one. Calculate the mean for the following data points. Remember, mean is just another word for average, and we use this symbol here, X bar, and it's the summation of your values added together divided by n. And so in this problem, you have 1, 2, 3, 4, 5 numbers, so n equals 5. N equals 5. And if I add up all those values together, what do I got? 26, 35 divided by 5. So that means x bar is equal to 7. And 7 is B. 13 is B. Question number 15. Find Q1, Q2, and Q3 for the data sets. Remember, the Q's here represent quartiles. And I was trying to help you guys think that quartiles... what happened? Quartiles, well, just traced all my work. I don't know how that happens, but we'll keep going. Quartiles represent like quarters. 25 cents. And there's like 4 of those for $1 whole dollar. Does that make sense? So there's 4 quarters to $1. So this represents 25 cents. Q2 is 50 cents, 50%, and that's 75%. So let's go ahead and take these numbers. We're just going to write them in order and put check marks. It's so easy to get lost in all that data. See, I missed one already. 5, 6, 12, 13, 15, 18. I missed one already. 22. And 50. This is how I can double check. I just write out how many numbers I have. 4, 5, 6, 7, 8. So n equals 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So this is a even, and my blue line represents the median, or Q2. So if you think about this, over here on the left side, under in green, this represents the lower half, they call it, lower half. And in this lower half now, we need to basically find the median of the lower half. Okay, now you don't include the median. So even if this was an odd number set, you don't include it. So here, this represents the median, right? Because there's 4 numbers. There's 2 numbers to the left and 2 numbers to the right. Well, there is no number for me to pick, so I'm going to have to take the average of those 2 numbers. Okay, so 6 plus 12 divided by 2 is 18 divided by 2. That means my Q1 represents the 9. Quartile 1, this blue dotted line, is the median of the lower half. Okay, so the median, sorry, we didn't even calculate this one here. 13 plus 15 divided by 2 gives me 28 divided by 2, so Q2 is equal to 14. And then let's go ahead and pick a different color over here. Purple. I'm going to have, again, the purple represents the upper half. And it represents those 4 numbers, 15, 18, 22, and 50. And now we need to basically find the median of the numbers in purple. So there's my median. And I'm going to have to add those 2 numbers. 18 plus 22, finding the average of those 2 numbers to find basically the median of the upper half. So 40 divided by 2. And this will give me a 20. Quartile 3 represents 20. So which one of these has 9, 14, and 20? So that would be choice A. 15 is A. All right, let's go down to page 3 now, and I have question number 20 for the box plot. So let's make a box plot. So box plot has a number line, and then above the number line, you're going to have things that look like this. You're going to have a dot, and then a line, and then a box, and inside the box you're not going to draw the horizontal line, you're going to draw this vertical line, and then you'll have something that looks like this. Okay, so what are the parts of these? This one is the minimum, so you have that one. This left part of the bar represents Q1 or quartile 1, which you have here. The this bar here represents the median. Some people abbreviate it with MD, or they also call that Q2. So those are all the ones that have but we know Q2, it represents the median as well. Okay, let's try to find another color here. The right side of the box represents Q3. And then, oh, and the median there. And then the last one is the blue. This is the maximum. Max. Okay. So the only one that actually had all of those was A. 20 is A. Now, I definitely want to also double check that each of these parts right here, each of those represent 25%, right? This is 25, this is 25%, and this is 25%. Okay, so some big ideas here is why do you want to use the interquartile range for distributions that are skewed? Okay, so let's see if I can change this a little bit to show why it's more skewed. Whoops. It's the same idea as like way out here, okay? And how do you draw a curve to this? Your curve would be something like this, okay? There's nothing really over here. Can you see that big gap right there? So that kind of represents, I didn't do too well, but I wanted to kind of show that you know, there's really no much data here. The data is more on the right side. How do I know that? This little whisker, this little part right here is small, so all the data is clumped up over here, right? 25, 50, 75% of our data is all right there. And this long whisker, that long whisker means there's not really a lot of data over here. So you're going to use the 5-number summary. And again, I'm trying to point out that the IQR is a good way, Q3 and Q minus Q1, to figure out the center, the measure of center. Okay. All right, let's go to question number 25. In a stem and leaf plot, the stem part of the data value is 347 is, okay, so let's just say I wanted to represent 347. Okay, I would not use this, no, because this would represent 34, right? And 3-7 would represent 37. So I wrote orange, no. So the leaf cannot represent orange. We said that would be a no. But if I draw another one, and remember, this is the stem, this is the leaf, and the stem here represents times 10, so that would give you 340, and then that 7 would give you 347. Okay, so my leaf has to be 725. The answer is B. And another reason why over here, if you did this over here, this would represent times 10, so that would actually be 30. So you wouldn't have, again, that's why I would, this part, let's make it obvious, no. All right, number 26. What is the range of my data? Remember, you're going to have to put this in ascending order. What does that mean? Small to big. Let's do that. So negative 13, negative 3, negative 1. Does that say negative 7? I think that says negative 7. Let's try that. And 0. Negative 13. Let's try that again. Negative 13, negative 7, negative 3, negative 1, and 0. And we're going to identify that the range is the max minus the min. So my max is the highest number, and the minimum or smallest number is over here. So let's write that. So 0 minus negative 13. And you'll recognize that my answer is a positive. Now, what does that mean? The reason why it's a positive 13, not a negative 13, if you notice that the formula again has that negative sign, you have to subtract. So 26 is B. And if you think about it, the range has to be a absolute value. It has to be a positive number. Okay, question number 27. Bar graphs are used to represent, you have some numbers or choices in here that we haven't learned yet. So some 2 vocabulary words you should put your finger on it is these 2, dependent and explanatory, which we'll learn in chapter 2. So not those 2. Quantitative is numbers that you can take average, that can take the mean or average. And qualitative, like qualities, what kind of qualities would you want in a significant other? These are categorical, or they are words, or if they are numbers, if they're numbers, can't take average, right? Like your house number is a good example. The room number, the classroom room numbers, it wouldn't make sense to take the average. Okay, so bar graphs, what kind are they? They are the responses for for bar graphs are qualitative. So qualitative is our answer. Because there I'm asking, do you have a pet? And the answer is yes or no. So yes, no, do you have a pet? And then that's how many they have, right? And the answers are either yes or no, which is categorical. Okay? All right, so that finishes up page 4. All right, question number 28 says calculate the standard deviation for this sample. All right, so I'm going to go ahead and do this all by hand, and of course the calculator can spit that out for you. But just in case, we go back, and I might ask you to do this by hand. If we ever go back to the classroom, there's 5 numbers here. So n equals 5, and so I'm going to find the average by adding up all those numbers. 2, 5, 3, 5, and 4 divided by 5. That means I have 7, 10, 19 divided by 5. Punch that into my calculator, and I get 3.8. So the mean that I need is 3.8. So I take all of these values, 2, 5, 3, 5, 4, and our formula for standard deviation is taking all of the numbers and subtracting it from their mean, adding those all up, and then dividing our answer by n minus 1. So I have the numbers there, and now what I'm going to do is we're going to subtract those numbers minus the mean. So we're going to subtract it by 3.8. All right, what do I get? I'm going to get negative 1.8, 1.2, negative 0.8, 1.2, and 0.2. And we don't have to put them in order because, remember, spread only measures how far away it is from the center. Okay, now I'm going to square those numbers. So let me write that in colors. What I have over here, we have the numbers in our list. That's these numbers. We're subtracting it by the orange, which I just did above. And now we're going to square those numbers. Okay, so negative 1.8 squared gives me 3.24. 1.2 squared gives me 1.44. Let's make that a little nicer. Come on, Mr. Ing. Negative 0.8 is going to give me 0.64. 1.2 squared. So again, what we're doing is we're just taking all these values and squaring them. We already have that from above, 1.44. And negative, or 0.2 squared is going to give me a 0.04. Okay, so now what we're going to do is we're going to take the summation, which basically means we're going to add up all of these values. 0.64 plus 1.44, 0.04. And I get a summation of 6.8. Okay, now we take that number and we're going to divide it by n minus 1. So standard deviation of our deviation, xi minus x bar, that gives us 6.8. And then purple, our n value was 5, so 5 minus 1. So just clean that up, 6.8 divided by 4. And let's change pen color here. This gives me standard deviation to be 1.7. Question number 28. For the sample is n minus 1. And we forgot, so that one's wrong. I forgot in our formula that we need to take the square root of all this. So if I take the square root of 1.7, this gives me a standard deviation. Let's pick what color do I not use? S is equal to 1.3038, and the closest one that matches is D is our correct answer. So take your final answer, what we had before, and then take the square root. All right. the box plot below answer the questions. The minimum value for number 31 is, it's kind of hard to see, but that's a 3, and they're just counting by ones there, so there's my minimum. So 31 is D. And 32, the interquartile range, this would be a Q3 minus Q1. So Q3 is the right box here. So that would be a 9. And then quartile 1 is the left side, which it's really hard to see, but that's a 5. So if you subtract those two, you will get a 4. So the IQR is 4, which is number 32. The answer is C. Okay, if 33, if the set of data of 49 data values, n equals 49, has a variance of 36. So variance, I'm going to write this out, equals 36. Okay, now variance has an abbreviation. If you look back at your formula sheet, it is the standard deviation squared. Let's make sure you know that. That represents standard deviation. Then the standard deviation is what? So how do you solve for s here? All you have to do here is take the square root of both sides, and you get s equals 6. Remember, the opposite of an exponent is the square root. And in that case, our standard deviation, so 33 is B. So that's the relationship between the two. So if you, let's put it the other way around. Let's just say you had the standard deviation. Let's just say it is 6. Well, how do you go to s squared? So remember, variance in orange is s squared, so you would just square both sides. So I'm kind of showing you how it's circular. You get s squared equals 36, or the variance. All right, the following table shows the frequency distribution. So remember, frequency basically just means count, of the heights of 49 walls, right? Like walls on a house or a building. I'm just going to write 49 just in case we know, okay? So it says, use the table above to answer the questions. So remember, the classes are what goes in these bins. So this is between 50 and 52, something like this, okay? And I don't think we're asked to create one, but I'm just trying to give you a visual of, you know, you do histograms, right? Something like that. Okay, so the number of walls whose heights are less than 55.5 inches. Okay, so 55.5, zoom in here. This here represents, kind of think of it as 56.0. So 55.5 would include all of these in blue. So 5 plus 8 gives us 13. There are 13 that are less than 56 inches. So walls that are less than 56, or think about it like $56, that would be 13. So question number 36, the answer is B, 13. All right, what is the class width? Or you can think of it as the bin width, okay? So again, what does this orange here represent? This represents 50, 51, and like 51.9, okay? So the 52, well, I take that back, because the next one says 53. I think it was 53.0 to 55.9 in some ways. So this 50 to 52 here goes up to 52.9. Okay, so let's look at that. So basically what you would do is you would subtract these two values. 52.9 minus 50 gives you 2.9. Or if you round up there, you'll get question number 37 to be C, right? All right, let's try question number 38. Which value in the given data set would affect the mean? Remember, the mean is just, simple word here is average, okay? So you can do a couple things here. You can give yourself a quick number line, 0, and just count by thousands. 1K, 2. And I just want you to create a visual, right? You always, in math, it's always good. I messed up. Let's move it over more. Is that neat? Ran out of space and I created space. Cool. 6, 7, and 8K. Okay? So 5, 6, 7, 8, 9. 6, 7, 8, and 1 over there. Okay? And then the 40 is like way over here. So what is my data going to look like? You have the data, you have data over here, right? And it's being pushed way out here. So the question is, in this outlier or extreme case, which one is it pulling from over here? Or which one is doing all the pulling? That would be our outlier or extreme value. That would be A. 38 is A. Number 39. Which graph would be used to represent types of cars sold in Jeddah? Okay, so types of graphs. We're going to skip that one because we haven't talked about time, so 39, skip that. All right, 41. A student scored 82 on an Arabic exam that had a mean of 88 and a standard deviation of 6. He scored a 58. The student scored a 58 on the mathematics exam with a mean of 60 and a standard deviation of 5. Which of these exam scores has a better position? Okay, so let's kind of summarize what we got here. We got two different types of exams. You have an Arabic or language exam, and then you have a math exam. And it's hard to, when you're comparing, let's write verses or something in here. When you're comparing two types of data, it's hard to compare because one of them had an 82 and the other one scored a 58. So you're like, well, they totally scored way better on the Arabic exam because it seems like it's higher. But that's wrong. Because in order to compare these two, you need some kind of ruler, a common ruler, to measure them, to see who's better. And what you do for that is you use z-scores. Z-scores. So my z-score formula is z equals the data minus the data point minus the average or the mean divided by the standard deviation. So I'm going to write that 2 times. And what we can do from here is then we just compare the two z-scores and see which one is higher. All right, so for the Arabic, we scored an average of 88. So 82, so they scored an 82 on the test, minus an 88 divided by a standard deviation of 6, okay? So that's a negative 6 divided by 6, so they have a z-score of a negative 1. And for the math, he scored a 58. So even though it's a lower score, Look at the average, what other students are doing. 60 divided by 5. Okay? That's a really bad 5. 5. So negative 2 divided by 5, that's going to give me a negative 0.4. Okay? So let me draw a graph and maybe this will make more sense to you. I'm just going to draw some random normal curve. And here's the measure of center. This is the average, which everyone does. Okay? Now, to compare the two, the blue, the Arabic test, negative means below. So we're going to learn later on, but a z-score kind of looks like back over here. Negative 1, z equals a negative 1. If you think 0 is in the middle, you're below, way below people, okay? Now the math test, he only scored a negative 0.44. So this is negative 0.4. So this is the lowest. Low score, this would be a high score, right? Positives and negative z-scores. So which one, which of these exams has a better position? Math was higher, yes. When it says no difference, they're basically stating, are these equal? That's no, so I have that so far. The Arabic exam is better. No, it's not true, because a lower negative z-score basically means you're further away from what the average what people are doing. And we have one of those. So the answer is 41 is A. All right, let's do this one. 41. From the drive below, approximately what is the total number of observations? Very hard to kind of see this graph. And you see temperature down here, measured in Fahrenheit, and you have a cumulative frequency over here. That's what it says. Cumulative frequency. So cumulative just means you keep adding on and into the total. Okay, what does that mean? So, if you come over here, the total number is this number right there. So for number 42, my answer is 50. There's 50 days in which they recorded the highest temperatures, and that's crazy to be that hot. It must be super desert, right? But the goal of relative frequency is you keep adding them up, and so the total, or the number of observations, is right there. Now, if they change it to a cumulative relative frequency, let me write that. Cumulative, the word relative just basically means a percent frequency. Then they're adding it up to be 100%. Okay, so pay attention to those words. All right, let's go over the next one. If a data contains values lower than the Q1 minus 1.5 times IQR, then these values are called, the answer for 44 is going to be called, am I writing here? Outliers. This is the lower fence of outliers formula. Just draw you a quick visual, right? You have some regular numbers in white here, but if any numbers are going to the left of this fence, this is called an outlier. And then the upper fence is is any numbers to the right here or greater than these values, that would be considered an outlier. But this particular question is just the lower numbers to considered an outlier. Number 45. Following data represents a group of students' grades. Okay, choose a correct frequency distribution. Remember, frequency just means to count. So let's count them. Maybe I should have just color coded it. How about that? How many A's? 1, 2, 3, 4. And how many B's? 1, 2, 3, 4. And you're doing some kind of visual over those. The common mistake would just be to cross them off, but it's not wrong, but you kind of just want to see your data still. 1, 2, 3, 4, 5, 6. Okay. D's, 1, 2, 3, 4. And then F's. 1, 2. What? Why did I do that? That's okay. And just to double check, because I'm crazy, there's 4, and then going across, you have 1, 2, 3, 4, 5. So 4 times 5, you should have a total of 20. So 4, 4, 6, 4, 2. That gives me 20. So let's just double check. The one I see that represents that one is D. Right? That's the same one. So the answer for number 45 is D. And then you have the answer key below. Okay? So hopefully that was super helpful for your chapter 1 test. See you guys. Good luck.